And recording. Cool. All right, so today, the only difference between this lesson and the last one we covered, this is 3.3 in our last unit, but this is comparing. So it's comparing the minimum maximums. It's comparing the average rate of change. And the minimum maximum, we're talking about that's just within a function. You know, if this function was related to some sort of sales of an item, the maximum that we would look at would be here, right? If it was the minimum, this would be the lowest sales point. So say if that was sales over the year, you'd have a month that had less than the maximum. So I mean, there's obvious importance with that, right? If you're assessing the success of your business over months, you look at different intervals, see what's happening, and you make trends. So at the following year, you know, I sell everything in November. November is when I make all my money. You got to plan like that if you're running a business, because not every month's the same. Things happen. So we're assessing that and the average rate of change, the AROC, which is just between, you know, we're talking about this function. If I have this interval, right, which I would denote, with these type brackets to show, you know, between 3 and 10. Say if this is at 3, this is at 10. The AROC would be looking at the average rate of change between those 2 points. So I would basically take the x and y from each of them, right, and plug it in to find the rise over the run. Now, that is going to be the same thing, but now we're going to have two functions involved, and we got to just compare them. I do that too. So to start, though, minimum maximums, we're going to start with that. Minimum maximums, we have standard form of the parabola right here. Pretty easy, pull out A, B, and C. Step one. Step one, pull out A, B, and C. Step two, plug it into the vertex form of the equation. That's going to tell me where, as far as my x values go, where I need to line up to find where the maximum is. But that just tells you where it is. You know, if I know that there's I plug these in and I find that my x value for the vertex is here, what else do we need to know in order to find where the point is, right? How far up and down it is, right? So if this was my x, this is my x. To find where the y value is, essentially I want to find, because I know it's at 2, but I need to find what the f of 2 is. I need to plug it back in and find what the y value is. Okay. So we're going to use the vertex formula here to find our x value, and then you have to plug it back in to find your y. When A is positive, happy face, so we have a minimum. The bottom of the parabola is on, at the bottom. When we have A is negative, it's facing down, so we have a vertex on the top. So those are the main differences we're going to have to deal with today. All right, let's go ahead and start with g of x up here. Go ahead and identify A, B, and C. Plug it into our vertex formula. So we have A, B, C. Which function has a greater maximum? So we're looking at that. And if you are in deep contemplation about this, good morning. All right, if you were in deep contemplation, you have to take a moment, shut your eyes, and really go deep into it. You might figure out that A is -4. It wasn't that deep. B is
8.
C is
3. Yeah. I was thinking about it, and I missed my exit.
Still in that smash match.
you made it. All right, what's my x value, or the x value of the vertex going to be? -8 over to -4. So my x value of the vertex at the vertex that's going to be 1. Okay. So if for g of x, right, is going to have this vertex of 1 and what? How can we now find what the y value is for that? What do you think, Ella?
You plug it into the original.
Plug it back in. Okay. So g of x, let's see what g of 1 is. G of 1, -4, 1 squared plus 8 times 1 plus 3. So this is negative 4 plus 8 plus 3, which is 7. Okay. So we just found out the g of 1. First we used the vertex formula right here in our a, b, and c values. I found with the vertex, it's at x is equal to 1. Then I take that 1, I plugged it back in. G of 1 is equal to 7. So our vertex for this is at 1, 7. 1, 1, 2, 3, 4, 5, 6, 7. So this is our vertex for g of x. That's the highest point. It's a parabola, so I'm guessing that, well, I can make some estimate. I know that's at least the vertex up there. So you may think, well, it's going to be a lot of work to do that twice. Why do we not have to do as much work for f of x? What form of the parabola of the quadratic is f of x in? Vertex form. Vertex form is nice because it's in this form. Maybe you want to write this if you forgot that. F of x is equal to a times x minus h squared plus k. And remember that this is always x minus h. So h in this case, if it's x minus 5, h is 5. If it was x plus 5, then I would know h is negative 5. Because that negative sign is part of the fundamental. It's part of the vertex form. So we could see for f of x, okay, so for f of x, we have the vertex of what? Tell your neighbor, what is the vertex for f of x? So we're going to have an x and a y value. HK is, okay, so it's going to be like this. HK, just like alphabetical order, right? H and then K, X and then Y. So essentially it's H and K. That tells you, essentially if it was X squared, the origin would be where the vertex is. So you're saying how much of a translation to get to where the other vertex is. So let's see, Belto, what do you think for H? 5, good. Adriana, what do you think for K?
3.
3, perfect. 5, 3, done. Vertex, I love it when it's in vertex form. This is our vertex form. All right, so let's go ahead and do 2, 3, 4, 5, 3. And they're both negative, so they're both opening down. Sad face. So which one has the greatest maximum? The actual answer to the question is actually really easy. This one, g of x, you could say g of x has a greater maximum. Remember that minimum and maximum. Let's see, what are they called? Extrema. So the extrema is defining both of them. If it has a minimum or a maximum, we instead of saying minimum or maximum, we would just say the extrema. The extrema is it's the extreme. It's the extreme part of it. All right. Here we go. Aaron, pull that blind back just a little bit, please.
It's on the record.
Actually, that made it level. That's uneven here. Yeah, just close all the way. Perfect. All right, we got it. It doesn't want to close. Can you reach up a little higher on the curtain to hold that? That looks like it. Okay, that's perfect. Now I see there's no shadow. All right, bring it back if you got a little distracted. Let's look at this one here. My first question. Okay, the following table represents the decibels made by sand booming. So there's this thing called sand booming. Anybody ever heard that before? No? Sand booming, let's see, the sound made when dunes shift with the wind. So if you've ever been to sand dunes, like there's some in Grover Beach near San Luis Obispo or Pismo Beach. There's some out in Death Valley. I haven't seen any others in California, but they're all over the place. I'm sure there's more. There are no sand dunes out of California, sorry. Those are called sand hills in Africa. No, just kidding. They're all sand dunes. California just has a few, and I was limiting my role to California, which is not smart. So yes, they're all over the world, and when they move, they make a lot of noise because of the friction, and they're actually really loud. They're really loud. Like, it'd be hard to fall asleep if you were in a real sandstorm. Let's see. X represents the energy in joules. F of X is the decibel rating. And I got some interesting information about Krakatoa, which was the loudest sound that was ever made. It's a volcano in 1855. It's pretty wild. It's pretty wild. I'll tell you some details on that. Yeah, it's crazy. So when I say some facts, you can add some. Indonesia. Yeah. Yeah. You could hear it loud. I'll tell you in a sec. I got some details. All right, I'm going to ask you right here. Which, let's see, compare the AROC over the intervals negative 0.999, negative 0.99, and 9 to 99. Okay, so how about this? We're going to break this up. Here's the divide right here. Right here. So Eliana, you're on this side. And then Jackson and Hayden, you're on this side. Okay. So if you're on the door side, I want you to do this interval. Find the AROC for this. If you're on the other side, window side over here, then you're going to find the AROC for that. Okay. Let's see. So this is, we can call this our A, we can call that our B. We can call that our A, we can call that our B. And I'll just bring this to your attention again if you forgot. And this will be like my 15-second kind of breakdown of this one. So the AROC is just the slope. It's just the slope. It's a rise over the run. So we find the difference of our f of x, which is our y values, and we divide that by the change in our x values. Okay. It's just the slope, rise over run. The way we're going to do it, though, is if you had this function right here, you would plug 2 into the function. That'd be f of b, minus plug 1 into the function. That'd be f of a, over 2 minus 1. So you would set it up just like that. We did that last Thursday, so I'm not spending too much time with it. But you basically now over here, instead of 1, 2, which is an easy interval, here we have negative 0.999 and negative 0.99. 9 and 99 might be a little easier to work with. Sorry, door side.
Wait, what is the function that we're plugging into?
Oh, hold up though. This, I just realized this doesn't give us the function, so we're just going to look at, these values right here, right? So this corresponds to our y values, that's to our x values. So just note and look, I know that for this one over here on the bottom here, we're going to end up with negative 0.99 minus negative 0.999. I know that I'm just going to be subtracting b from a. And on the top, you have to find what the corresponding f of x value is for your b and your a. So not a whole lot to compute. Every one of you should finish this in like maybe a minute. Right. Taking notes? No? Yeah? Your Navy test? Or okay. You can't do it all the time, but keep going. You gotta know the rules. Break them correctly. Know the rules to break them correctly. You gotta know this. Alright, let's see what we got. Alright, let's bring it back. What values am I going to put in for this? For my f of b minus f of a. F of b is 0.99 negative. That is right here. Right? So I know that it's going to be f of b right here, which is 0. Minus, what was f of a? Justin, what was f of a?
Negative 1.
Negative 1. Okay. So as I work this out, I see that on the top, I'm going to end up with positive 1. And what did you get for the bottom? Yeah, sure. Justin.
0.009.
0.009?
Yeah.
That makes sense. Here's our AROC for this interval. Thank you. Someone on the left side want to give me some numbers? Not really.
I can.
All right, Luke, what do you have?
Um,
What's on the top?
on the top, it's 4 minus 3.
Good, because we have B. B is 99, so f of x, here's already our work's been done for us. 99, sorry, 4.
4 minus 3.
Good, 4 minus 3. I always put this 3 in parentheses, just because if your number ends up being negative, you won't accidentally forget that. Honestly, that's probably the crux, computing-wise. Okay, so keep that in mind. I would say this, parentheses, let's do it, second value. All right, and then Luke, what's on the bottom?
And then 99 minus 3.
Okay. So we work all that out. It looks like we're going to get 1 over 90.
Yeah.
Okay. So let's see. Now tell your neighbor which one has what we're looking for here. Compare the AROCs over the intervals. So how would you compare those two? How would you compare those two? What do you say? What do you say for that? How do you respond? Bless you again twice. You owe us. All right, let's see. How about Alan? How would you describe or compare these two? What would be a good way to compare this one and that?
The slope for AROC is not for the negative side. Negative 0.991 is the larger, smaller. No.
Would it be smaller or bigger?
Larger.
Remember when we divide by a decimal, right? It's gonna actually make it a really large number. So what is this number going to give us if I were to work this out? What is that going to be, like 9,000? 111.1? Repeating. Wow. All right, that's what that equals. Interesting. And how about this 1 over 90?
0.0111.
Repeating. Yeah.
2. No,
Yeah, that doesn't happen. Your calculator is tricky. Just puts a 2 in there. Throw that away. Can we break that calculator right now? Just kidding. All right, so how would you compare them now that we have actual values? What would you say?
The slope will be bigger for negative 0.999 and 99.
Yeah. Let's call it the average rate of change. The slope is how I kind of relate it, like on linear scale here, or linearly. Okay, so that's a good way to compare it. You can see this is obviously much larger than that. So it increases, the average rate of change increases. It's increasing at a greater rate between that interval than over there. So, like a lot. Most of it is happening right there in our early negative values. Most of the growth. All right, thumbs up, sideways down. Can we do this? I thought so. Good job. All right, today's classwork is actually in the